This tutorial gives an introduction to Revelations Report. This program can be launched from Exodus Ignition or from Revelations Master. The purpose of this program is to show the status of current runs started by the Revelations Master, or even after Revelations Master is finished, to compare different cases to see which ones resulted in a better match and where the match errors are or can be improved. From Revelations Master, if we start it up, we can see that we have used this button, Report Run Status. And if you do use this option to start Report Run Status, you would be able to right away get the data file that the case is running and use that to start the analysis of the runs. If you don't start from Revelations Master, then you start as is. You have to get a new data file, the data file which was previously run before. So if you get a new data file, in this case I'm going to go back to my network run folder and pick up the data file I've been working with, this 4-well case. Open the file, and it shows that I'm now trying to look at the cases run for this base data file. If I were to show the tried cases for this base data file, it's going to read through and tell me what cases have run for the base data file, and it shows me the tried cases, which case number, regression cycle number, cycle number, try file name, run by computer, objective function, run status, the regression parameters that were used. And the ones highlighted in yellow would be the best ones in successive time, the lowest objective function as we go try multiple cases. And so we may want to compare the initial best case, this one here. We click on it, the highlight line shows a green line. It's highlighted, it's selected. It's that case to report. And if you go down to the end here, and this is the other good case, the last best case that we've got, and this is the cycle 30, regression 1, cycle 30. We go and click that one, and then we can add selected cases, 2 selected cases in green from below to this list. So we compare two tried cases and see what the wells are. If we had another data set where we have the same wells, observed historical data, the same observed times, and we simply had change in this base data file the regression parameters that we use to try to match the wells, then we can also open up that data file, select the best tried cases from that regression, and compare them with the results from this current base data file. So if you did that, you will be able to open up more files to compare. To keep this current simple, I'm going to report this particular 2 tried cases. I click on that, and it's going to read the 2 tried cases and show the wells that are in those cases, and they must be the same number of wells, the same historical wells that we have been trying to match. And these are the series parameters that we are going to that we can show. Typically this would be the sum of all the incremental rates, the sum of all the cumulative errors, the OR rate calculated, the historical OR rate. So this difference is the incremental error between the calculated and the historical rate multiplied by the weighting factor for that OR rate series. And the incremental error at each time is cumulated to have a cumulative error as increasing with time. Similarly, we would have a gas rate calculated by the case, the historical rate as observed, the incremental error being the difference between the gas rate calculated and the gas rate historical multiplied by the weighting factor, and that will be the incremental error at each time the observation was made, and the cumulative error will accumulate the incremental error over the whole period of time. And the same thing goes for water rate. CUMOI, if we had chosen to use the series CUMOI historical, we could get also the CUMOI calculated and historical difference, incremental error, cumulative error, and so on. And this is average pressure, and this is Bornholm pressure calculated. These are the times that we can select to see what any of these particular values are at this time. Select all incremental errors, we'll simply select all this series. Select all cumulative errors, we'll select the cum series, and report errors, a percentage of final cum error in order to normalize the error so we can make more meaningful sense of it. I'm just going to show you the oil rate calculated, oil rate historical at all times for all the wells for the cases. So we can show a table or we can show charts, graphs, charts. For charts we can show by case or by well. So by well we take each well and compare for the two cases the selected parameters at the selected times. By case, we will take that well case, all the selected wells, and compare the series for all times. And we will have another graph for the second case, and so this is by case. So but for the second case, we would have another graph for all the wells and all the parameters and all times. So let's choose by well. So by well, we're going to choose one graph per well for both cases with these parameters. Let's build those graphs and identify that by saying we're going to put in the word oil rate in the title. Oil rate in the title, and build the graphs. And the graphs are built. We just drag it over here. These are the graphs built. So by well, the oil rate, what name was added to the name of the well. If you click on it, you would get the graph of that well, and you will be able to see the match, and we can see in both cases the match is pretty good, except in this particular case here. If I do utilities, highlight cursor position, and we get a better match for regression 1 cycle 30 than the previous case. And we can also look at the graphs for the second well, and you can see it all matches pretty well. And we can look at the display, next well, and next well, and we can also look at the match for the gas rate. Gas rate calculated was a historical, and build new graphs by well using the gas rate in the title. Pardon me. And build new graphs, and this is gas rate graphs. And you can see in this case I'm more familiar with these graphs. You can see that the second line is the regression 1 cycle 1. The dashed line is the regression 1 cycle 30, which is the better case, the second better regress case. And we can see that we have a better match. Again, the match is not much different. Better match here maybe. Better not much different match, and slightly better match. And we can do the same thing for the water, water rate calculated, historical rate calculated, and put this as water rate, build the graphs, show the graphs. Sorry, this one here, water rate graphs. Water rate is pretty close to the actual historical rate, so it's improvement on the water rate match and getting closer to the actual, and trying to get closer to the peak water rate. So those are graphs, and we can also show by table. So show by table, for example, by table we can choose to show for example, the water rate, or yeah, we can show the water rate, the same thing in the table. Grab the table here, and the table shows us the sort order. Currently we sorted by case, well, and time. So this is one case, and the wells, and the time. So for the case ending here, case 1, all the wells, and for each well sorted by time. And this is the difference between the water rate and the historical rate. And we can go down and see that each of these wells, you can compare them. We can resort it by, say for example, by time, by well, by case. We can see that by time, at this time, for each well, the case, you can see the difference between the calculated versus the historical rate to get an idea of that. And we can also show cumulative errors for these wells and report as a percentage of error. So reporting wells as a percentage of error, summing all wells, sum all errors, all times, show the table, and sort it by, say, by time, by well, by case. And we can see that in this case here, let's look at without the percentage of error, and show a table. And we can see that for the cumulative error, for these two cases, sort by time, by well, by case, we can see that for this case 1 and case 30, for all wells at that time, the error has dropped by approximately 4,000. And we can analyze the error by looking at individual series and see which series has had the best improvement for that particular match. So this is a quick introduction to the Revelations report, whereby you can show tables and graphs of selected cases and use it to analyze where the errors in matching are, which wells are the best matches, and so on. Thank you for your time.